jump at that question at once. Nobody's heard of factoring by grouping? Factoring by grouping is basically factoring using your GCF methods, which is why we reviewed GCF a little bit before we were going to do our notes for today. So factoring by grouping only works if you've got 4 or more terms. So 4 terms or more. I've seen it where you've had 6 terms, so you could do your grouping a couple of different ways with it. You could do groups of 2, so you would have 3 of them, or you could do groups of 3, so then you would have 2 of them. You could have 8 terms, anything along those lines. So factoring by grouping means you have 4 or more terms. So what you're actually going to do is you will take the first 2 terms and you're going to group those ones together. I like to make that little, people call it a flower box there underneath those 2 because those 2 are grouped together. And then we're going to group the last 2 together. So I've created 2 groups. I got my first 2 terms in one group, my second 2 terms in another group. So then looking at just the first flower box, or 2x cubed minus 3x squared, just those 2 terms by themselves, what is the GCF between those 2? X squared. So I'm going to put x squared here, set up my one set of parentheses just like we would do for all of our other GCF factoring, and then remember we divide by the x squared. So we would have 2x minus 3 in there. So GCF factoring. So now let's look at the second flower box, our negative 8x plus 12. We're going to do the same thing. What's our GCF there? Not just 4 though. Remember, when that first sign's negative, you want to pull out a negative 4. So I want to pull out a negative 4, divide both of these by negative 4. So I would get 2x minus 3. So see, so far just GCF factor. So then you see this stuff here in the parentheses, how it matches. That means we're doing it correctly so far. That has to match in order for us to do the next part. If those don't match, that means that maybe you did your grouping, your GCF factoring incorrectly, so we should check that and then go forward. So those have to match. So now we're going to do GCF factoring again, only this time, what is our GCF? I just highlighted it yellow. What's our GCF? Our GCF is that 2x minus 3. It's that binomial. Your GCF can be 2 terms. So just like I would with any other GCF, I'm going to take that out in front. Only because it's 2 terms, I have to put it in parentheses. And then I'm going to set up my other parentheses. So again, remember, we would go up here and divide by 2x minus 3. Divide by 2x minus 3, just like with any other kind of GCF. You divide by what your common factor is. So what's left to go in the parentheses? X squared minus 4. So then once you've done your GCF for the second time, grouping always has GCF done twice, you always have to look at them and see, okay, can I factor again? Because remember, that factor completely is that unwritten rule that we always have to follow. So can we factor 2x minus 3 again? No, there's no GCF there. X isn't squared, so we can't break it apart anymore. How about x squared minus 4? Yeah, that's going to be a dots factoring. So I'll set up my 2 sets of parentheses for my x squared minus 4. So remember, it's x and x to get you that first term. Signs are going to be what? Different. So we'd have a minus 2 and a plus 2. And then you still have to bring down that 2x minus 3. That is still part of your final answer. I always say it's kind of like your sibling that you bring to the store. You tell them you have to wait outside. But when you leave that store, that sibling still has to come home with you. Otherwise, mom's going to be so mad. So you left 2x minus 3 hanging out in front of the store, so now you got to bring them home. So 2x minus 3 is still there. All right, let's try it again. So again, we got 4 terms in our next example. So let's group the first 2. Group the second 2. Make our little flower boxes. So within the first flower box, what is our GCF? They both have a b to the first being our smallest, and they both have y squared. So by squared would be our GCF there. So we would get b plus 1 in our parentheses when we divide. And then what's our second GCF? 3, so plus 3. And then I get b plus 1 again, and I know we are doing a great job so far because our parentheses are the same. They're both b plus 1. So we're going to take that b plus 1, put it out front because that's our GCF this time. If I divide by b plus 1, we're left with that by squared plus 3, which neither of those can be factored again, so that one's done. That one just was 2 GCFs. All right, let's try our next two. So again, flower box. First 2 terms, and then second set of 2 terms. So within our first flower box, what's our GCF? X squared. So then on the inside, we would have c squared plus 1 when I divide both of those. So then for the second flower box, what's our GCF going to be? These are both negative. We want to turn them positive, so we'll take out a negative 1. So when I take out that negative 1, they turn positive, so we have matching parentheses. They're both c squared plus 1. So my GCF would go first, which is my binomial of c squared plus 1. And the second one would be the x squared minus 1. Can we factor either of those again? Which one? The x squared minus 1. That's a dots problem because it's subtraction. The c squared plus 1 is not going to be dots because it's got the plus sign, not a subtraction sign. So that would factor into x minus 1 times x plus 1. And again, you've got to bring your little sister home from the store so she gets brought down. I always say little sister because I was the little sister that my brothers always had to bring home. Otherwise, whew, they were going to be dead. All right, let's look at the next one. So again, flower box. So flower box first 2, flower box the last 2. What is our GCF in the first 2? 4. Our GCF in the last 2? Negative 1. We got to change those signs. By taking out that negative 1, now I have the same thing inside my parentheses. I got x squared minus y squared. So we'll put my x squared minus y squared first. And then I got a 4 minus 1. Can I factor either of those again? Yeah, x squared minus y squared. That's dots factoring. So that'd be x minus y, x plus y. And then in the past, I've had a lot of people go, that last parentheses doesn't seem right. But it's right. We did our math all correctly. It's just what is 4 minus 1? This would turn into a 3. 4 minus 1 gives us 3. So you can either leave the 3 at the end I have a hard time doing that only because I had a math teacher who would never let us do that, and she would literally rip our papers up in front of us if we didn't put it out in front. I will never do that to you, don't worry. But the 3 just has to be there somewhere. You can put it at the end. You can put it in the middle if you really wanted to. Our commutative property allows us to change that order. I had some kid who just liked being different, so they would write it like that. That's fine. All 3 of your factors are there. It doesn't matter which order they're in. All right, 2 more. So flower box the first 2, flower box the last 2. What's our GCF for those first 2? Good. So x squared, and then we're left with an x minus 2. Our GCF for the last 2, positive 3. So then we would have an x minus 2. So then our GCF again would be the x minus 2, so we pull that in front. And then we got the x squared plus 3 that comes along after it. Can we factor either of those again? Nope. So that one's done. All right, and then our last one for our notes. First 2, last 2. What's our GCF for the first 2? 7x squared. So then we would get a 2x minus 3. How about for those last 2? Ooh, close, not negative 2, though. Negative 1. There's really no number that's actually in common with 2 and 3 other than the 1. So that's what you would take out of there. So then GCF is that 2x minus 3. Inside the other parentheses would go that 7x squared minus 1. And then can we factor that again? No, is 7 a perfect square? No, so it looks very dots-like because you got that x squared minus 1, but the 7 isn't a perfect square. So you can't actually do anything with it. So that's your final answer.